Part 13, that is CAN bus connector. In this tutorial we are going to see depth knowledge about the CAN bus connector, that is what are the pins in the prime agenda is what are the pins in the CAN connector and what each pin resembles. So this is what the prime agenda of this tutorial. Let's see first the CAN connector. So there is no standard for CAN bus connector because this also has been many criticized interviewers. Being frank, that the interviewers asking that there is what standard the CAN bus connectors has been established. Then we used to tell the CAN bus standard like ISO 11898, so whatever we have seen in the previous tutorial, that standard is only for the 120 ohm resistance, but for the CAN bus connector there is no standard has been made, but only thing is that CAN bus 120 ohm resistance is made with the standard. The higher layer protocol defines or a few preferred connector types, or this is 9 pin, that is DSUB, then 5 pin mini C or micro C, or 6 pin DOTH cable. So these are all the three connectors that has been used for, but now we are preferring the 9 pin DSUB. See, this is the 9 pin, that is we can say the DB9 also. So here we have the 9 pin, see what each pin does. See the pin 1, if we start, so we used to always starts with the, from our side we have to start counting from the left to right. So here 1 2 3 4 5 and again 6 7 8 9. So for example, if you're going for an industrial standard, and if someone has asked you to do some soldering or do some connection with the pin number 6 means, sorry 7 means, then you have to come from this way, 5 6 7. By mistake, if you come from this way, then it will come 6 and 7 and 8, so you will make it on 8th pin instead of 7th pin. So you should always remember that from your side you have to count like this: pin number 1, like 2 3 4 and 5 6 7 8 9. So this is how you have to make use of it. So let's see pin number 1. The pin 1 is a data carrier detect, that is DCD. So this pin is responsible for the transmission of data, that is whether the data has been transmitted or not, or the data has been received or not. So it will just detect, it's like a flag. So if the data has been transmitted or received, it will makes as a 1. Then here pin to receive data, so the RD, this will just whenever the data has been transmitted, as you know, the CAN is a multi-way communication, that it will transmit as well as receive. So it will, whenever it receives, then it will get the data from this, that is RD. Pin 2, pin 2 is a responsible. Then pin 3 is a transmit data. Again I am telling, CAN is a multi-way protocol, that is multi-way transmission. So whenever you want to transmit the data will be transmitted from this pin. Then pin number 4, the data terminal ready. So whenever the data terminal is, so it will always acknowledge whether the data terminal has been ready or not. If it is ready, then it is also kind of flag, so it will give only the ready not ready, as here it will get like detect yes or no. Here it will, these are all boolean boolean terms. So it is yes or no, that is 0 or 1. Again here also 0 or 1. Then this is ground, it is for safety, that CAN protocol. So this may connect or this may not connect, as you know the CAN is a differential in voltage. So the ground is actually not required in many cases, but is for the safety purpose, it is recommendable but not so advisable. So advisable is recommendable is yes, if you want you can do, else no, but if you do, it is a good, that is a recommending thing. That's it. And here the pin 6 is a data set ready, that's DSR. So here again, how the data terminal ready, here the data set, what are the data is set to transmit or receive, so it is ready. Then here pin 7th is request to send RTS. So again it is the name itself we can understand, so it is just a requesting to send the signal or data. Then here it's a clear to send. So before sending every signal, the CAN will always ensures that there will be no signal reflection, or there is no corrupted data, or there will be no junk data in the way. So it will clear all the data before it send anything. Then final is ringing indicator, that is RI. So it is a kind of indicator if there is any there's any need of intimating something, then the ringing indicator will do. So but you will not use all these pin. Yes, definitely you will use pin number 5 you may use, then you may use pin number 2, you may use pin number 7. So that's it. Then apart from that, depends on your project, so which pin you will use. But also, if you, for example, if there is any problem with the data reception, so you have to check this first, whether this pin is damaged or not, because in most of the cases this pin or this pin used to damage, because people used to handle it, very robust way. So these are all sensitive. If you are just plugged in, and if you just tilt the direction, if you plug out, then it will break. So in that way you have to ensure whether it is working or not. So this transmit data, receive data, this request to send, so this pin has to be ensured. If there is any error, you have to check these first, whether is there any problem with the pins. If no, then you can go for it. If yes, then you have to first change this before checking others. So this is the overall pin diagram. Let's see here you have a male connector. There is db9 male connector and female connector, as I said. So if this is a male connector, yes, we have seen here this is a male connector. So I don't want to give you the more explanation about the male connector as well as female connector, but still, so if it is like this, it is a male connector. And as we are adults, so no issues on that. If the instead of pin, if it is has a hose that the pins may get into that, so it is a female connector. So just remember, in male connector you have to count like this, and in female connector you have to count like this. So from means from male connector, in your point of view, in male connector it is a left to right, female connector is a right to left. So this is how you have to see. But most probably female connector will not get damages, because it is it is fully, it is wrapped with the plastic, so there won't be stuffed with plastic. So there'll be only holes that this male connector has to accommodate. But as it is a pin, only the male connector will damage, so you have to ensure this. So you don't want to check with the female connector. But for your understanding, this is a left to right and it's a right to left. So this is what but some way, some in some cases the pins may just broken, and it may accumulate in the female connector, that you have to remove if it is there. But you can easily identify that. So this is what the things that you have to check in the male and female connectors. So yes, this is how it looks like in real time. So this is yes, this start from 1 2 3 4 5 6 7 8 9, and here it starts with 1 2 3 4 5 6 7 8 9. So in this way it should you should see. So this is the in a real view how it will be. So here again we have given the connector diagram, we have the specification, then see the here we'll start with the 9, I'm sorry, okay, 1 2 3. So we have to see this ground is be in the 5th, okay, 1 2 3 4 5, okay, terminal power, oh, indication is not there. Okay, so it will start with the, so it will start with here, it will start with 1. But it just, you don't want to confuse with this, just see how it will be. Okay, so can low is one pin, then can high is another pin, can ground is another pin, then can shield is another pin. Then apart from that, you don't want to see here can be its optional power, so we don't want this. So only this thing you have to understand, can low, can high, and can ground. So here the can low is second pin. Okay, so in this table is wrong, but only thing is you have to see can low, can high, and can ground. These three we have to accommodate. Yeah, here we have actually, yes, sorry. So here we have the can low is a second pin, then third pin is ground. Okay, okay, so this is also they have given, fine. So can low is a second pin, can high is a sorry, third pin is a ground, then sorry, then can high is a seventh pin. Yeah, this is a can high. So as you know, it is a male connector. We in most of the cases we used to talk in terms of the male connector, because as I said, the female connector is that there won't be any the dependencies, like it will be just fitted in the in the ECUs, so or the CAN setup. So only the male connector you have to consider and you have to give. So it will start with always 1 2 that is from left to right, and here CAN 2 is a low, CAN low, sorry, pin 2 is a CAN low, pin 3 is a ground, and pin 7 is a CAN high, and this is optional ground and this is optional power if you want. Again, this is optional shield, but only these three are required. So see, this is a male connector viewed from the connector side, or a female connector viewed from the soldering side, that is the opposite side. So this is how it will works, and these are all the three. So I guess you got something in this tutorial, that how the CAN connector is. So this is what the connector, and here we have the twisted pair cable. So in our next tutorial we'll see about the CAN bus error detection techniques. That is also a very important concept that you have to know. And yes, until then, just watch once or twice, so sorry, twice or thrice, so that you will come to know more. And as it is a theoretical and it is a protocol wise, so you have to remember this stuff, that to if you want to deliver to somebody, so it will be a very short and crispy way that you can really learn a lot. So I'll catch you in another tutorial.